So hi, my name is Barry Solomon. I'm here to talk about the Perceptual Computing Software Developer Kit. First of all, just a question, how many software developers, app developers we have in the audience? Great, great. How many of you have downloaded the SDK or gone to the website, looked into it? Excellent, thank you, sir. So, this is great. This is a great opportunity for us to talk about our perceptual computing initiative and how all of you as developers can get involved. So the first question that is often asked is, what is perceptual computing? At its core, it's about enabling end users to interact with their computing devices by going beyond touch, mouse, and keyboard and using new modalities such as mid-air gestures, speech, face recognition, and as well as 2D, 3D object tracking, and whatever else is coming down the pike technologically. So perceptual computing it's the whole idea is adding additional senses to the brain of the PC. So with the Perceptual Computing SDK, which was launched in beta, it's still in beta, we launched it last fall at IDF. It works with the creative interactive gesture camera, which includes an IR depth sensor. And then the next question is, well, is this just for gaming, or can we use it for other things? And Intel's vision is to change the nature with which users interact with their computing devices. So we're looking at establishing a broad ecosystem of applications as well as developers to implement perceptual computing in all types of applications. As you could see, gaming, entertainment, productivity, education, medical, various lines of business, immersive teleconferencing. There are many, many uses for the technologies that are in perceptual computing, and we want the world to make use of perceptual computing however we can. So, as I mentioned, the Perceptual Computing SDK was launched last fall, and now let's show you a little bit about it. So what Dimitri is showing here is, this is a tool, this is one of the sample programs that's shipped with the SDK, or any of you can go to our website at intel.com/software/perceptual, download the SDK. This will be one of the sample programs that comes with it. It's called Gesture Viewer. And first thing I want to show you is our finger tracking. We can track all 10 fingers simultaneously. As you can see, the fingertips are indicated by the red dots. You've got the circles in the palm of the hand show the normal angle to the palm, a red dot on the forearm, and then that blue circle there is a grasp point. The algorithms, and the algorithm is from SoftKinetic, with our partner SoftKinetic, calculates a grasping point based upon the depth map. As you can see, the depth map, what you're seeing there is the point cloud being generated by the time-of-flight infrared camera that's in the creative interactive camera. We also support poses, peace sign or victory, thumbs up, thumbs down, and gestures, swipe right, swipe left. So this is actually part and parcel of the SDK. You can download it right now from our website. But we haven't been, and even though this was released earlier this year. We've been busy. We've been developing even more capabilities. So let's go to Treasure Cave. So this is a technology, a capability that we have first demonstrated on publicly on Monday here at CES. And this is a virtual hand. So a user can essentially reach into the screen on their PC and manipulate 3D objects in 3D space. And what this is doing is taking that depth cloud information that's captured by the infrared camera, and rather than just calculating the fingertip positions, it's calculating a fully articulated hand skeleton with all of the joints. As you can see, it's still in experimental beta stage. We'll be improving this over time and making it available to developers as an experimental module this year. So one thing I want to point out is that Intel's been made a very significant investment in perceptual computing. We actually have an entire division of scientists and engineers who are creating these new technologies, creating partnerships with the best worldwide, and we are taking these technologies and packaging them into the SDK. As I mentioned, we released last fall as a beta. We're still in beta phase. We're up to, we've been releasing new releases of the software about a monthly cadence. Our next version will be available later this month, and we expect to have a gold release, a production-worthy release, sometime this quarter. So this is another demo that we are showing at here at CES, and this is the game Portal 2, and what we've worked with 6 Sense to add this to add the gesture capability with the Perceptual Computing SDK. And as you can see, well, it might be a little hard to see Dimitri, but he's essentially manipulating that cube in 3D space with just his hand. So he can move that cube up, down, right, left, in, out, and then by turning his hand, he can actually turn the cube. Now this would normally require mouse, keyboard, some other fancy peripheral. Here you could just do it with your hand. Great, why don't we go to okay, now here's a demo that I particularly like because not anti-game, but it's nice to see a non-gaming usage for the SDK. So this is an application from our partner TouchCast, and what it's doing is it's extracting Dimitri's face, which now you're all very familiar with what he looks like and can ask him to perform demos for you, and superimposing it on a background. So effectively, we have a green screen sort of capability, which in the past would have cost a lot of money, required a lot of equipment. And the nice thing about this usage, it places the user right in the content, and there could be many, many different usages for this, from some kind of immersive video conferencing to potentially presentations to even entertainment. So this particular demo has gotten a lot of attention. So the SDK is available for free, as Craig has mentioned earlier. It's a free download at intel.com/software/perceptual. You can also order the camera from there, or if you ask the right question, maybe you'll get one here today. The SDK currently supports 4 usage modes. We have the close range, finger, and hand tracking. And just, I want to point out that our focus is on close range. It's from 6 inches to about 3 feet in front of the camera. It's really intended to be used by users while they're using their computing device. And that's been a big focus of ours. And as you can see, the accuracy and fine-grained nature of our finger tracking and hand tracking is enabled by that close range. The SDK also includes speech recognition from Nuance. It uses the engine from Nuance Dragon Assistant. We also include face analysis and tracking, and 2D, 3D object tracking, which gives you the ability to define any object, and then once it comes into the field of view of the camera, the depth camera can track it across the field of view. Actually, I just made a mistake. It's not the depth camera. That algorithm actually uses the RGB camera to do that. Now let me talk for a moment about the camera. This is it's going to be available later this year commercially. It's going to be brought to market by Creative Labs. Intel's worked very closely with Creative to develop this camera. It uses a chipset from our partner SoftKinetic, who is a leader in gesture technology. In fact, we also, within the SDK, the hand tracking algorithm is from SoftKinetic as well. The camera includes a HD 720p webcam that operates at, I think, 60 frames per second. And it also includes a time-of-flight infrared depth camera that operates at a VGA at 30 frames per second. And it includes dual array microphones. So you can accomplish speech as well as depth, as well as having a webcam in there. The camera, as you can see, it's small, it's light, it's USB connected, so no external power supply. And once again, it's part of that experience that Intel's creating around close range perceptual computing, interactivity. So, as I mentioned earlier, we're currently supporting 4 usage modes. The close-range depth tracking, facial analysis, which can detect the presence of a face and can recognize the 6 or 7 landmarks on the face, eyes, nose, mouth, as well as recognize some attributes such as smiles, blinks, and age groups. We've got the 2D, 3D augmented reality, and speech recognition, which includes voice command and control, short sentence, dictation, and text-to-speech synthesis. So what that means is with the SDK, you can add any one of these usage modes or any combination of these to your application. And one thing I want to point out, this is a journey. We're just beginning. And you will see Intel adding new usage modes over time, as well as new devices. We are looking towards the future with this. So this is, I know there are some developers in the audience, and developers not satisfied till they see a block diagram. So here's mine, although I'm sure it's pretty high level, but I think it explains a bit about how the SDK is constructed. So as you can see, we have algorithm modules for each of the usage modes that we support today. As I mentioned earlier, 2D, 3D object tracking, the close range hand and finger tracking, face analysis, and speech recognition. Now, the SDK, what we've done is we've created an extensible framework. So over time, it's extremely easy for us, or even for you as developers, to add your own algorithms. The SDK exposes both high-level APIs, for instance, with the gesture tracking. If you simply are interested in capturing a couple of poses and gestures, we expose those APIs. However, if you're interested in creating your own algorithms, you can capture the raw depth data and create your own algorithms and add it. So the SDK also it takes the burden from the app developer of having to manage input devices. It also supports provides multi-mode support, and as I mentioned earlier, we want to see developers. We want the world to be using more than one of these usage modes at the same time. For instance, gesture plus speech plus face analysis within a single application. Whatever makes sense should be available to the app developer. We're certainly interoperable with the other tools that we have showcased here today from visual computing at Intel, so OpenCL, IPP, Media SDK. Another aspect of the SDK that's very important is that it exposes the power management state of the platform, of the PC it's running on, to the application. And we're anticipating, as you can see now, the camera's small, easy, you can easily carry it around with you. We're working on integrating the camera into laptops and all-in-ones in the future. But in laptops and ultrabooks in particular, power management is a huge issue. And if the application knows if the device is in some sort of a power savings mode, it can take appropriate action so as not to deplete the power. By the way, the camera right now just uses USB power, so it dissipates less than 2 watts. As I mentioned earlier, there's we've created an extensible framework. We're anticipating new usage modes being added in the future, or developers such as yourselves can create new usage modes and new algorithms and add it to the SDK, as well as new devices. And there will be new devices. And finally, privacy is obviously a very, very important concern by end users, and we're doing our best to address this. So we've included a privacy notification tool. And what this does is developers are required to embed that API in their app, and when their app is invoked, it notifies the user when the camera is turned on. So, as I mentioned, the SDK, we're trying to take some of the burden off of developers so that they can quickly focus on implementing their apps and don't have to be experts in perceptual computing or depth camera analysis, and just add speech recognition, gestures to their apps. Very easy to get started. The SDK is downloadable for free at intel.com/software/perceptual. You can order the camera at intel.com/software/perceptual. I mentioned it's not available commercially yet, but it is available to developers for $149. And on our website at intel.com/software/perceptual, we've got a full set of documentation, tutorials, we've got some showcase applications you can download, and we also have our support forum. And we strongly encourage you to ask questions, get involved in the community. So, this year we're going to have the depth camera, the creative interactive gesture camera available as a peripheral. And right now our focus is really getting your interest as developers, getting you involved in the SDK, and generating innovation. So as part of that effort, we've launched the Perceptual Computing Challenge, which over the course of this year, $1 million in prizes will be given away. Last month, several weeks ago, we launched stage 1 of the contest. It runs until about February 20th, and for stage 1, the total winnings add up to about $250,000. There'll be a number of prizes, and developers, you can submit your prototypes there. They don't have to be market-ready apps, but we'll be judging the prototypes. And one other thing I want to point out is that as I mentioned earlier, we want perceptual computing to be all-pervasive in the computing experience. We want to go beyond gaming. So we've actually created 4 categories for the entries. Games, productivity, creative user interface, and multimodal, meaning apps that use more than one of the perceptual computing modes, such as gesture plus speech, or face tracking plus speech, or what have you. So there will be a second phase to the challenge. We're still working out the details. That'll start in the March timeframe. I encourage you all to go, enter your prototypes, jump in. Water's fine. You can go to perceptualchallenge.intel.com, or just go to the website I've been mentioning a lot, intel.com. Intel.com/software/perceptual, and you could link over to the challenge site. In terms of the timeline, as I mentioned earlier, we released our Beta 1 in mid-October. Gold release is scheduled for later this quarter. The camera will be available later this year, and we expect apps to be available commercially. So I just noticed the red timer. I want to leave some time for questions. So let's work our way. Start from the front. There is a vocabulary. The question is, how is the speech controlled? There is a glossary or vocabulary of several 100,000 terms. Currently, we have U.S. English. We'll be adding 9 other languages later this year. And once again, this is done in partnership with Nuance, who I think many of us recognize the name. And Nuance Dragon Assistant, which is a full speech recognition application, will be available on quite a number of the Ultrabooks shipped this year.
That is impressive, the nuance. I bought an all-in-one PC, and it has gesture controls. Nothing like this. This is way better. And then there's, like I said, Microsoft Connect. Is there, for app developers using these gesture controls, will there be a way to create one app that will take advantage of all of the different cameras that will be available, or is it going to, kind of be one-offs?
Well, the SDK will in fact support different cameras as they become available. Right now, for this year, we're focused on supporting the one camera, the creative interactive gesture camera.
I had a question. Speech recognition was mentioned, and over the years there's been obviously a lot of challenges in that area with dealing with accents, dialects, speech tone, etc. Have you seen similar challenges when you do the gesture-based with musculature, body hair, things like that, skin tone? And what challenges do you continue to see in that regard?
In short, the answer is yes. I think the challenges have to do a little more with the lighting in the environment, as well as the granularity of the movements, as well as the user's view of the monitor or the panel, and those are the things that need to be compensated for. So if your movements, the user's movements are too fine-grained, it might be difficult for a user to actually effectively use gesture. You might actually have to dampen the experience. You may also have to compensate at different angles for the viewing angle of the user. This is why we're making the SDK available now. We want to hear your answers, and it's going to take a while for developers to hash through all of these usability issues. We know they're there, but we know, and they're challenging, but we know that once they get solved, they'll create a much better user experience.
Hi, I have a couple questions, if you don't mind. First, what about us HTML5 developers? Moving forward to SDKs to support us, and also, how are you handling the background noise in relation to the facial recognition and such?
Right. Well, in terms of HTML5, we're definitely thinking about it. We actually have a prototype in the lab using HTML5. As you can imagine, we need to work on getting the performance better because it's abstracted from the hardware, but we're working on it. We want to make perceptual computing available to web developers, ideally through a JavaScript interface. So your second question was background noise. Once again, that's something that you can help us with. If you can come up with algorithms or filtering, we'd love to have you as part of our ecosystem, and there'll be opportunities for you to perhaps expose it to other developers. So I have run out of time now, unfortunately, and I know there's a lot of interest here, so what I'm going to do is hang out outside, and perhaps we can chat.